Okay, so technical issues, sorry about that. So today is the French, la journée de la souveraineté numérique française. I'm Italian, I will be speaking in English. So I will be talking about Skrub, which is the Python library that I develop together with some others. I'm the lead developer. The tagline of Skrub is machine learning with data frames, and the idea is that Skrub sits in between working with tabular data in pandas or in polars, and preparing that data so that you can train a machine learning model with that. So I'm going to start with a corny phrase, which is boost your productivity with Skrub. And the idea is that Skrub is there to help you save some effort in doing a lot of the usual things that you have to do to prepare data so that you can use it in machine learning. So I will be giving you a few examples of this. But throughout, the idea is that we are doing good engineering so that you don't have to write the code. One thing is that everything you will see today, so Skrub is fully compatible with both pandas and polars. So depending on what flavor of data frame library you have, you can use either. And it's not using narwhals for that, if you actually know that. And then all the transformers that I'm going to show you are fully compatible with scikit-learn, of course. So you can put them in your pipelines if you have them, and they should save you some effort. I mentioned a pipeline, so the idea is I gather some data, I explore the data, pre-process it somehow, do some feature engineering, and then I build a scikit-learn pipeline, and hopefully I profit. However, if you're like me, and you've done a lot of data processing, you see something like that, a table, and you say, oh, here we go again, because you know all the pre-processing that goes into that, and it's quite heavy to do. So this is the first I would say the flashiest feature of Skrub, which is the table report. And it's this very fancy looking table, as you can imagine, that is actually interactive and that is giving you a full preview of what's inside your data. You can look at it and see all the columns that you have in your table. You have a high-level view of the columns, so you know what is the data type, how many null values you have, how many unique values you have. You have a distribution tab that is showing you histogram bar plots for all the columns that you have in the table, so you can immediately see that, for example, the assignment category column is very unbalanced, so you might have to deal with it in some way. And finally, you have an associations tab, which is telling you that a couple of columns are very strongly correlated with each other. So this might be useful if you are dealing with a linear model that does not really like that kind of stuff. An important thing about the table report is that everything that you've seen is completely offline, so you don't need a Jupyter notebook, you don't need a kernel that is that's spinning underneath. You just save it as an HTML file, and you can load it in a browser, and it's going to work from there. Now that we have explored the data, I have this very small display example that I've written in pandas and polars for the sake of it. And some of it is like some dirty columns, some are fully nulls. There is a weird date format. There are some columns that I want to keep. And just to give you an example of what it takes to clean it with pandas, this is what you have to do. With polars, this is what you have to do. And with Skrub, this is what you have to do. So basically, with the cleaner, we are saving all of that effort because all the coding needed to select the good columns and drop the useless ones is done for you. Also, here I am parsing the date as a date time, even though I had that weird format from before. Talking about date times, this is the datetime encoder. So the datetime encoder is once again taking a date as an input, and is going to give you all the parts of the date as new columns. So you don't have to write all the lines of code involved in that. And also, you can also add periodic encoding if you need that. That's especially useful for linear models because that helps with catching some features that otherwise would be lost. If you're dealing with numerical features that have a lot of outliers, like all the spikes in this plot, here, like most of the data is in -2 + 2, but then you have all of these spikes, and you have to kind of deal with those. if you use traditional scalars, you might run into some issues because if you have the robust scalar, then you're going to be fine with the inliers. The outliers are going to mess up everything. Standard scalar does not like outliers either. What Skrub does is have the squashing scalar, which is just going to clip all the outliers to a finite value, so you know that for that particular feature, you're not going to have very weird spikes. You're just going to have a fixed range for that. Talked about date times, talked about numbers. Now there are the categorical features, meaning string or text, and the most important thing about those is the fact that they have a certain number of unique values. So low cardinality means the size of a t-shirt. So you have a finite number of unique values, and you can encode those using the one-hot encoder. The problem is that here we are dealing with data frames, and data frames are dense, and so they don't like one-hot encoder that much, especially if you have too many unique values. So for that, we have a few encoders. The default one is the string encoder that are there to kind of help you with high cardinality features. Basically, they keep the number of components fixed to a certain number. By default, it's 20. So string encoder is latent semantic analysis, if you're familiar with the term. But if you are working with data that has context or free-form text like reviews, descriptions, or anything, you can use the text encoder, which is just wrapping the pre-trained models from the Hugging Face hub. You can download them and get the features out of that. So that is useful, particularly for this kind of, if you have context or text. You can put everything together in a table vectorizer, and what it does, it's going to give you an encoded version of your starting data frame by first applying the cleaner that I've introduced a few slides ago. Then it's going to split all the columns by data type and by number of unique values, and then it's encoding every column separately. So this is kind of what it looks like. For low cardinality columns, you just do a one-hot encoding. For date times, you have the datetime encoder. For high cardinality, you get the string encoder, and so on. Now we can build a predictive pipeline, and this is what you have to do if you want to do it properly with the ridge, or you can just use a tabular pipeline from Skrub, which is giving you all of the same, including the table vectorizer plus the goodies that you need for the ridge, all for you in 2 lines. And this is kind of how I feel whenever I am working with Skrub, because if you are just dealing with default scikit-learn, it's kind of can get a bit wordy, but with Skrub, everything is much easier to digest. So now we have a pipeline, because we can explore the data, pre-process the data, do feature engineering, and build a full scikit-learn pipeline with a tabular pipeline. However, this is not always enough, because sometimes you have data spread over multiple tables. Sometimes you want to, and you want always to avoid data leakage. Maybe you want to tune more than just the hyperparameters of your model, and you want to guarantee that your pipeline is replayed exactly on new data. So you have done all of your preprocessing, all of your selection of parameters. You want to make sure that all of those parameters are replayed exactly on new data. So when a normal pipeline is not enough, the Skrub DataOps come to the rescue. Because the DataOps extend the scikit-learn machinery to multi-table operations, and they take care of data leakage for you. They track all the operations that you do in a computational graph, which we call a DataOps plan. And they are transparent and give you direct access to the underlying object. This means that if you're working with a pandas data frame, you actually have access to all the functions in the pandas, in the pandas library. You don't have to re-implement them. They let you tune all the operations in the DataOps plan, and guarantees that all the operations that you've done are reproducible because of DataOps plan, as I was talking about. And finally, they can be persisted and shared very easily. The DataOps work by wrapping around user operations, where a user operation is any kind of data frame operation, or a scikit-learn estimator, or some custom user code. So if you have to download a file from a remote path and you have to turn that into a pandas data frame, you can just do that, wrap that into a function, put it in the computational graph, and it's going to re-execute it for you. So the idea is that DataOps record user operations so that they can be replayed later in the same order and with the same arguments on unseen data. To start with the DataOps, you need to define a kind of an entry point for the DataOps plan, which are the variables. Here it's baskets and products. And you need to mark some of them as X and Y. The idea is that if you tell Skrub, this is X, whenever it's doing some kind of validation, it's only ever going to look at the training split. So it's basically dealing with the leakage for you, because it's never going to do a join between the test split and whatever other tables you have. So it is really keeping track of all the samples for you. You can apply transformers. So here I'm applying a table vectorizer, and I'm getting the vectorized product. I'm applying a bunch of data frame operations, a group by, a merge. I'm dropping some features. And then I'm applying a machine learning model. In this case, it's a extra tree classifier. Then you can inspect the full plan, which is this execution report. And now you know what table vectorizer is. You know what this is a table report. The idea is that the execution report is for you to understand what you are actually doing with your data, because you can see all the steps of the code, you can see where the step was created, and you basically see what is the output of each node in the graph. You can save this, and whenever you're reusing the model, you can just load it again. So in a few months down the line, you don't know what this particular model is doing, you just load the execution report again, and you can see. And once again, this is like the table report, fully offline. You don't need a notebook just to load it. It's just an HTML file that you can load in a browser. You can export the full plan in a learner, which is like a scikit-learn estimator, but takes as a dictionary as an input rather than X and Y, which means you can pass arbitrary values to this dictionary. And then you can save it and load it and apply it to new data. So here I loaded it in the loaded learner, and I'm passing a new dictionary with the variables that I had defined at the start. I was saying you can hyperparameter tune anything in a DataOps plan, and you can choose from a list of options. You can choose numbers in a range. You can turn on or off a Boolean flag. Or you can say that a full set of operations is completely maybe arbitrary. You maybe don't need it. You can turn it off. And hyperparameter tuning with scikit-learn, if you're familiar with it, is also very complicated, because you have to define the grid by yourself, and it's kind of a complicated syntax. What you do with the Skrub DataOps is just saying, okay, I don't know which regressor I want to use, so I want to choose from ridge and random forest, and I'm not sure which are the correct parameters here, so I'm going to choose an alpha value or a number of estimators. So you are nesting these choose functions. Skrub is going to build a full grid for you. And then once you have the full grid, what you can do is you can run a hyperparameter search with make a randomized search. Then you save the best learner without having to do the hyperparameter tuning again. And then you get this very scary looking parallel coordinate plot, which is interactive and is actually helping you figuring out what are the hyperparameters that you might want to look at. So you see that you can actually move around and select different things, and it's very useful for inspecting the results. There is more information on the main website, of course. The parallel coordinate plot was an example that the tutorial we gave at EuroSciPy 2025 on time series forecasting with Skrub. And yeah, so to conclude, what happens if you put together a table report, cleaning, a lot of powerful encoders, and a bit of chemical X with the DataOps? You get Skrub. So if you like, if you're interested in what I've just presented, here there are a bunch of links. I'm going to show a QR code in the next, in a moment about where you can find these slides. There is the website, there is a material website, we have a Discord server, you can follow us on Blue Sky and LinkedIn and stuff. So this is the final slide. I'm going to leave it here with the QR code that will get you to the Skrub materials webpage. So yeah, to wrap up, you have interactive data exploration with the table report, automated preprocessing with the cleaner, feature engineering with the table vectorizer, something I could not fit in the time, and then the DataOps, which are way more powerful than what I've just shown because of time. So yeah, thank you.